great to be here. Great to be back for another Open Data Week. This time of year is always when Open Data Week happens is a signal that it's about to be spring and cherry blossoms coming soon. And over at In-Situ, we also call it AR season, which is the best time to be out doing augmented reality and touching some grass. So I'm looking forward to that. I am Nick. I do community partnerships and ecosystem at In-Situ. Been doing this for about almost 3 years now. I have a background in civic technology, community management, and X design, which is VR, AR, all-encompassing immersive media. So today I'm here to talk about something which is an experiment still. And so I'm very open to feedback and ideas and comments and questions on this. This started as an idea that usually what we do at In-Situ is visualization, and that's usually a one-way street. So like you're seeing something that the city has made for you to look at, but it can be a two-way street, I think, and it's possible to actually use AR to create things, and even for ordinary citizens, residents, and city dwellers to create things in AR. So I've been experimenting with that a little bit, and I was curious how we could use this, not just for informing people, but actually for advocating, building across community. So start out with just a general question to think about, which is, what is the point of urban or architectural visualization? I think it's obviously not just, visualization doesn't just do one thing. It's not just for one person or one group of people. There's multiple layers, but we can start to untangle it by looking at some things. Like, for example, this is a tool that some architect recently vibe coded, I believe. It's called the anti-render. And so what it does is it takes an architectural rendering and it transforms it into a view of the same scene, but in a cold, rainy day in November. And it's a funny tool, but I think when you see, like, why would this tool have been created, even as a joke, then you start to understand maybe architectural renderings are made to make you feel good about the thing in the rendering, right? Maybe just soften your impression of it or allow it to be approved easier, or just kind of generally be okay. That's not the only reason that we visualize things. We also visualize things to understand something that might be complicated or have a conversation with a group of people. So at In-Situ, we like to think that we do support artistic rendering and visualization, but we also want to be a tool for discussion and conversation to help understand complex spatial problems, and also to make invisible things in our cities visible on the street specifically. So how do we discuss things in cities that seem invisible? And there's a lot of open data in New York City's portal about things that are invisible, like zoning. I think the commitment to make invisible things and open data visible was evident in all the efforts here in Open Data Week, but it can also happen in all these different ways. So my favorite example is this. Does anyone know what this image represents? It's from Switzerland, if that gives you any more ideas. So actually in Switzerland, there is a law that new buildings and additions have to have a representation of what they're going to look like before they're built. So usually this is in the form of height poles. There's a name for them that trace out literally, physically, the height of a new proposed structure so that people in the area know what's going to be built. I assume this would be an addition to this house. I forget the name of them, but there's some articles about them if you want to read more. I think it shows that this isn't just some new technological affordance that we have. It's a choice. We can choose how our processes work and what we make visible and how, to whom. So In-Situ, although we are based in the newest sort of augmented reality technology, that's the process that we're trying to encourage, is the process of sharing information where it is concerned. So on the street, at the site of a project, so that the people there can understand what's happening. And also people that are doing the project can see something in its living context and not just in a diagram. So we do all kinds of events and activations for our clients who are mainly planners, architects, community-based organizations. This is what one of the activations looks like on the sidewalk. All the AR that we use is based on mobile phones and tablets. We don't use fancy visors or glasses, although that may be coming soon. I don't think it's inevitable. We'll see. But the benefit of smartphones right now is that a lot of people use them, but also you can share the experience. So unlike a headset or glasses, you can look over the shoulder and actually have experience with people with you at an event you're going to, or perhaps bystanders on the street, which we have happen all the time, who can share in something that you're looking at. And that's very important to us. So we have the on-site mode, which actually places 3D models at a geospatial coordinate. And how that works is that your phone's camera and your GPS device on your phone is telling the app where you are and cross-referencing your phone's camera with Google Street View imagery and features in that imagery. So it knows where to place the building. That's a little simplification, but that's basically how the latest geospatial AR works. I believe this is a demo. This is not a real project, but it's in Hudson Yards. And it's showing just a building. Actually, it's from Texas that we were doing as a demo, but just showing it. We also have a tabletop. This is maybe the AR that if you've seen augmented reality, you're used to seeing with Amazon or IKEA, being able to preview stuff, tapping and placing it on your table and rotating it around. So this is what we're dealing with today. This is the specific technology we're talking about. But as I showed in the intro, there's other ways that you can visualize things on the street as well, or visualize things in 3D that are more lo-fi as well. And they all play together. A lot of times our clients will use the augmented reality, but use it as a filmmaking tool. So they'll make a video and then put the video on social media. One mayor in Columbus figured out how to use it to take a ribbon cutting photograph selfie before the project was complete. If you're a mayor, you'll figure out how to use it for mayor things. And if you're a planner, like in Hawaii, you'll figure out how to use it for things like policy development. So not just engaging the public, but they actually had to develop some new form-based code regulations in Hawaii for the wildland urban interface, they call it. And so to discuss those rules, they needed to convene planners, residents, and fire scientists, because they all had a piece of the conversation. And they should visualize what the rules could be by showing them in AR and how they actually meet the ground and the actual dwellings in the neighborhood that the regulation was proposed for. And then they didn't just use AR, but they used the same 3D models in a game engine and some 3D maps to do different things. Some other examples from a group in New Orleans that does community-based design using shade structures and showing shade structures before they're complete. And then an experiment that I did on the left, where we're starting to get into the topic of this event. I thought a lot of times we show shiny, fancy things, but it's actually possible to scan physical objects into AR too. And so why not do handmade models and make it more accessible that way? And we've done some experimentation around that as well. So today we're going to talk about a workflow to use your smartphone and laptop to capture existing streetscape objects and furniture, such as benches, public restrooms, bike shelters, public art, anything you can walk around basically, and turn it into a 3D model. And then take that 3D model, publish it in AR, and be able to view it in a different location. So the implication is that maybe some places in New York have very nice things on their streets and parks, and some places don't. So what if you could literally steal those things and recontextualize them somewhere else and start to maybe advocate for, why don't we have one of these over here? I'm not an expert in streetscape equity in the process, and there are projects ongoing, like I'll talk about NYC's Mapping for Equity project. So this workflow is an open question. Could this help with community advocacy? In what way? In some roadblocks to getting things built might be beyond what you can do with a nice media campaign, but for some things, maybe this would be useful. So we're going to talk about the steps one by one. Smartphone is pretty much all you need. All these apps are either free consumer apps or open source. There's alternatives for everything. So from 3D to AR to different things, you can always find a different way to do it. So I'm just going to show you the way I'm most comfortable with today. We're going to show you how to, once you have a 3D model, how to get it ready for AR. Usually they're pretty adaptable out of the box, but sometimes you have to optimize things. And so a lot of times when we work with planners and architects, they're used to these really heavy, large models made for engineering BIM purposes. And what we're trying to do with these new 3D interactive tools for communication is much more like a game designer or a video game models. They have to be a lot quicker so they can run in real time. So talk a little bit about that. And then we're going to end up with a location-based augmented reality model, a QR code-based thing that you can scan and see on your table in your room. So I'll go through this video one more time and stop a little bit so you can see what's going on. So this is a public restroom. It's an automated public toilet. They have 20 of these sitting in a warehouse somewhere that they haven't installed, I think because they're very difficult to site, but they have some Williamsburg and Madison Square Park, I think. So I scanned the one in Williamsburg one day in the blizzard. And what the scanning involves is basically you have to use a phone app and take a lot of pictures from different angles. So you see them walking around the object many times. Those pictures are what is turned into the 3D model with the structure from motion algorithm. And so once you have the 3D model, our platform In-Situ is one of the AR platforms where you can publish that model and see it on location. And you can either see it in a place you can move it around, or a place where you've pinned it to a geospatial coordinate. And I found out 311 actually has a request form for these public toilets, but they seem very difficult to get them. And I know there's a new pilot as well that Mamdani's approved for scoping out new public toilets. So this is the little video that I made about that project. And some open data to get started. So if we're looking for things to scan, a couple places we might look, and maybe you know more. And if you do, please type in the chat. Mapping for Equity project. So I believe Beta NYC's teams, and they work with students, go out and map a lot of these features like benches, lighting, play structures. And I believe they're using OpenStreetMap. Correct me if I'm wrong, but that's where one of the places you would go to find, and definitely go to the Mapping for Equity website to get a lead on some of that. There is also the Street Seat program, which I believe is being rolled into like the Dining Out program recently, but they have some data on where street seats have been located. If you want to scan some of those sort of brightly colored place, technical urbanism style seating, that might be a place to start. And also just going for a walk. I think it's interesting. I know a little bit about OpenStreetMap, but I was wondering, and so I was trying to ask the AI, maybe you guys know better, how does OpenStreetMap treat things that are just proposed or things that are desired features rather than things that are existing features? And it looks like there is a way to tag a life cycle of something if it's planned. And there's also a way to make a note for a request or requesting a feature like a water fountain. I'm not sure like how widely this is used, but it's interesting thing to think about, because once you do create a video or scan something you want to see somewhere else, how would you actually express that in NYC 311, different places, community board, something to think about. So I'm going to stop. This is the beginning of the sort of tutorial part. If anyone has any more questions before we launch into that, let me know. Okay, so I'm going to keep going. So we're starting with photogrammetry. Like I said, this is just taking lots of pictures from different angles of an object. It could be a big object as big as you can get around. Some people use drones and take video and images from an entire city block, but mostly at the human scale, we're talking about objects in the streetscape that you can get around. And it's good to be able to get up high too, but you can also use things like the selfie stick to get your camera up there. Oh, and Dimitri is in the chat from Beta NYC saying, yes, using OpenStreetMap, here's the Mapping for Equity project link, and thanks for the shout out. So the link is in the chat. So this image here is from a really good guide from the New York Times R&D department's photogrammetry guide. And I was just looking at the authors of that guide, and there's somebody that used to work for In-Situ like 4 years ago that helped write it. So it looks like a great guide with more detailed explanation than I can give here. The link is at the bottom, so I'll just copy that in the chat as well. So there's the number of apps. Today I'm going to show you how to use Polycam, which is one of my favorite ones on mobile, and it has a free tier. There's also an app called Scaniverse by Niantic, who made Pokemon Go. That calculates the 3D object on your phone's local compute, so it doesn't send it out to the web, which is interesting. And then if you want to be true open source route, there's a solution called Meshroom that implements the open source photogrammetry stuff. I'm going to talk about Polycam, but they're all pretty similar. And the ones that work on your phone are very nice. I really appreciate the convenience of being able to prepare the model for export on the phone. The best time to do this 3D scanning is usually you want to have even lighting. So a cloudy day is really good. If it's really bright and sunny, you're going to get hard shadows, and those can be maybe not what you want on your model, because it's going to bake all the lighting into this texture map on the 3D model. Pick a nice sort of kind of day with neutral lighting and head out and install these apps on your phone. In the app will give you instructions on walking around the model. Usually we do 3 rings. So you walk like it says in these images right here. You see there's a top ring, a middle ring, and a bottom ring. So you walk around the object once, keeping your phone locked on the target of the object, walk around at the mid height, and then walk around facing at a lower height. Once you do that, and Polycam will guide you on how to do that live and give you some feedback on how you're doing. They'll tell you to slow down and so forth. So it's good for beginners. Then at the end of processing, you will end up with a really cool 3D model that probably includes some of the ground and some of the surrounding features. And so once you have that, you may want to cut out the surrounding features or crop it just like an image. And this is how you do that. So I scanned this chess table in a park near my house. This is what the 3D scan looked like in Polycam on my phone. And you have a crop option. So a lot of the apps are similar. Scaniverse also has this. You can just crop in 3 dimensions around the object that you want to export. You can bring it up just above the ground if you don't want to include the ground and apply it. And it will leave you with just the part that you want. And so once you do that, then you basically export the model. You can also rescale in Polycam. So there's an option here where you can measure a side and then say how long it should be. If you want to rescale, this is great if you're doing miniatures that you want to bring up to scale. You can do that all in the app without having to open the 3D software. So it's really great. Now, in the export settings, there's so many different 3D models. There's a lot of the standards of 3D models are still evolving. So there's so many choices. It can be overwhelming, but GLTF is a new standard that's really good. I recommend GLTF. If it's not available in the app you're using, FPX or OBJ are also good formats. With OBJ, just be aware that it stores the texture image as a separate file than the mesh of the 3D models. A lot of times you'll have to import them together, or at least make sure they're in the same folder when you bring in the OBJ file to the place you're taking it. So at the end of this process of cropping and preparing your model from the photogrammetry app, you will end up with a model that you've exported. It should be around 40 to 50 megabytes. It could be as large as 100, 150, depending on what you're doing. That might be too large for this use case, but I'll show you how to make it smaller in a second. Optimizing your model for AR. This is based on In-Situ's platform, but holds true for a lot of augmented reality. The image texture on the model is just an image file. The format for that image file matters. So for us, at least, PNG textures are really good. And when you talk about textures of 3D models, people will say 1K, 2K, 4K. That just means 1028 by 1028 size, or 2K is the next doubling of that, and 4K is just like in your TV sizes and so forth. So 2K is good, optimized for detail. And then the size that we're targeting for In-Situ is 35 megabytes or under. So if it's 60 megabytes or 70, then there's a really great tool shown here on the right. It's a web-based tool called GLTF Report. So you bring in a GLTF file and you can optimize it. There's a script that you can run to optimize it. So I was able to take this model as 39 megabytes, and I was able to make it 7 megabytes just by running this automatic optimization. This is the website here. So you drag your file in. I don't know if I have a 3D file here. Let me see if this is. All right. So I have this 3D file, and you can see over here, there's a double caret. This is a script that you can run. So there's a bunch of stats here, and you can also change the exposure of the image texture, but don't worry about anything except for this script button. This is the optimization script that makes it smaller. There's a run thing here where you can run the script and it will make it smaller. At the bottom of this code, and if you don't code, I know it can be intimidating, but there's just a little tag down here that says WebP, which is the format of the image texture. If you change this to PNG, then the script will convert the image texture to PNG, which is compatible with our AR. Different tools have different needs, but so I'm just gonna change it to PNG, run the script, and then you'll see the size went down here. And so now if you re-export the model, it'll download a optimized version of it. So that's the quick way to optimize your 3D models. If you want to go further, I recommend these tools. So Blender is open source 3D software that's really amazing for all kinds of things. And you can use certain plugins with Blender to actually prepare these models like a real game designer would. So there's one called Packer.io that helps you make the textures a lot more efficient. And there's a tool called, this is the Packer.io website. So if anyone's more advanced and wants to get into that, it's their Blender plugin. And then there's another tool called the Agisoft Delighter. So when you take scans from the real world, they're going to have shadows on them. And you can actually remove those hard shadows if you want to remove them with this tool. It's a free tool from Metashape. And in addition to removing the hard shadows, one thing you can use it for is to make what's called a normal map. And this is what makes 3D models in games that have really fine details, but they're too fine that it would be too large if they put those fine details in the mesh. So they create a texture around the model that reflects light differently in different places. So you can make little fine bumps and stuff like that. And if you remove the shadows of the model, you can create one of these maps in Blender so that you can turn the image of your model that's been delighted into these little fine bumps. And so if you're going for real detail for public art and stuff, this could be a good thing to play with. I learned about this, by the way, from a project called Tenid XR, which is a digital heritage project scanning Tunisian archaeology sites. And they had really great guide for volunteers on how to do this, which is where I learned how to use this workflow with the Packer and Agisoft. That's the advanced method, but GLTF report, if you need to optimize at all, is really fast and really good. If it's under 35, you're good to go. So when you have your model and time to bring it into AR, I'm going to show you in situ. This is what I work for. So I'm just familiar with it the most, but you upload your model to in situ. It's no code. You'll be greeted with a 3D map where you can place that model anywhere and resize the object and then basically publish directly to an AR project. And it's a QR code. The object will be more or less where you placed it out in the world. You can go on site and adjust that position of the model and save it if you need to fine tune it. But for this project, mostly you'll be using the tap to place mode and just arranging it where you want, taking a video, and then that video becomes your tool for maybe spreading the word. This is the bench I brought into the park, and you can drag the orange ring to make it bigger or smaller. And then this is the QR code. So at this point, if you want to, you can try scanning this, and I hope that this will work for you because I just published it, so I haven't had a chance to test, but it should open App Clip if you're on iOS or on Android. You may have to download the in situ app from the Play Store first. It'll open a window of the project and ask for your camera permission. And then if you point at a flat surface and tap your finger, the model of the bench will load in. So I see it over here on my side, at least. It's working on my machine. I think Polycam did a pretty good job. It actually has some sort of like reflections, and the texture of the table came through really nice. It would be fun to place this in a place that doesn't have chess tables and see what it would look like. If anyone has any issues, just send me a message in chat and I can help get it up. So that's the workflow. My question to everyone is, how might civic media like this, so actual videos of things represented in data or maybe not represented in data, how might this support equitable streetscape upgrades? And I guess keyword is equitable. I know with 3-on-1 and a lot of tools where it's like the squeakiest wheel gets the grease. So maybe that's not always desirable for you. I guess you want to be the more squeaky wheel, but how do we actually use this to give more streetscape upgrades to the places that are not getting them is a question. I have a theory about using these immersive media, and the theory for change that I have is that we've been using this and pitching it as a faster, better project. So use the AR and you will speed up this one project's life cycle, help get the engagement faster, get the project through faster, avoid things going wrong. But I don't think that's the only place it stops, because I think if you use stuff like this to support co-creation and do more AR projects, more 3D building, then you can help to spread the word in the community and build civic participation. These activations can be persistent, so they can live on for a long time. They can spread by word of mouth. And I do think that, like, in addition to supporting the individual projects represented in those 3D projects, just the experience of connecting with groups and doing this builds civic capital, basically social capital, and having group experiences in general, whether it's for this new tech or not, is a good thing. We want to support more people going out and seeing for themselves, being on the street and encountering, planning where it meets the built environment. So thank you very much. I'd like to show you one more cool thing that I saw today, which is this person on Instagram was using the same technique, photogrammetry, to create origami of electrical box. So they took pictures of the box and made this paper version of it, and then they posted the file right on the box itself. So I think there's a lot of things you can combine. My favorite thing is combining the new technology with the more lo-fi stuff as well. So very curious. Yeah, paper. Fully like that. It's paper, included paper in the thing. Great. I can go back and revisit any part. We're at about 35 minutes. So if anyone has any questions or wants to revisit any part of the tutorial to get a little more detail, let me know. I'm curious also if you have any ideas, like what should we scan next? I really want the bike sheds, like the safe bike lockers, because I don't have a place to put a bike in my building. And I know they have one in Manhattan. So that's what I'm trying to find. But this is the place to start. So I'll leave it on this slide because it has the apps you're looking for: Polycam, Scaniverse, or Curie, or Meshroom. Does it work indoors as well? If you mean the photogrammetry, the AR, they both work indoors. So you can capture models on your table. There's a mode in the app. I think both Scaniverse and Polycam will say, are you scanning a small object? And then you want to put it on a table where you can walk around the entire table. Spinning the object itself doesn't always work. There's some modes where you can do that, but it's best to just walk around it yourself. You can also get these gimbals from DJI that will allow you to take videos and target a specific spot on the floor. They've got like a gyroscope in them that can be really helpful. And then there's more advanced solutions coming out, like this company XGrids makes something called the Portal Cam, where you can scan an entire space, like just walking through it with LiDAR and 360 cameras built into the device. So the smallest object I haven't scanned, but there is a category of photogrammetry for macro photography. So they've done like a bumblebee, and it's really amazing. I wonder if I could find it. And I didn't even tell you about a new 3D format called Gaussian splats, which is a way of basically, it's like photogrammetry except point clouds, but it's not very widely supported yet. But you can, oh no, I have to go to the cursed X. Oh no, this is here. So yeah, check this out. This is a bumblebee. So that's a macro photography image of a bumblebee, and you can see how the lighting is changing. That's the difference between a splat and a photogrammetry is just a 3D model with a photo texture, but a splat is like a point cloud, so lots of little dots, except that you can see they've been stretched like a paintball splat, and they also change color at different angles. So that's what makes it look so realistic. And I think this is coming soon to game engines and XR. There's already examples, but it's still cutting edge, and it's hard to, like, you can't 3D print this because it doesn't have like solidity, but there's more and more ways to do this stuff, and it's really fun to play with. So the chess table. Yeah, there was a game jam this weekend, and we made a board game to play on chess tables because I never have chess pieces. I don't really play chess, but I always want to use those in the park. We're trying to invent new games for them. And then the largest object, I don't know if I can think of a good example of that, but yeah, the people are doing entire cities like this. And I guess this is where we're heading now, is having these very detailed captures of entire cities. And Tokyo and Hong Kong have released as open data 3D maps of their city. So I hope New York City would do this. There is a 3D map, but it's for tax purposes, of course. This is the first 3D map they made. But the one in Tokyo is called Plateau. And yeah, it's like open and free. So it's a digital twin of Japan. You can download the models. And I think the reason why they're giving this away is because every company has a 3D map of your city now. Like Google, Meta, all the sidewalk robots are mapping. So there's all these different 3D models of the city by different companies to help their robots move around and so forth. The city should have a source of truth and also be able to mediate that. I think having a 3D map is very important, and hopefully we'll catch up on that regard. But yeah, this is where we're headed. I think this stuff matters a lot. There's some threats that we have to think about, especially with people wearing more cameras in public and We rely on street view imagery taken by cars to locate our 3D models, but so it doesn't actually work well in a lot of pedestrianized areas off the street grid for the one mode that I showed earlier, because the imagery wasn't taken by people, it was taken by cars. So it's interesting, like path dependency. But as more people, if they do wear those glasses, you might get more data from them or from a sidewalk robot, and yay, my tech works better, but at what cost? So you do have to think about that and who owns these data. One of the things I would like to do is start a repository. So what can be open source here? I think all the tech, the photogrammetry, the AR has some open source stuff as well, but the models themselves, you can release 3D models as open source. You could release them with a CC0 license or any license and create repositories. Digital heritage projects do that. And there's a site called Sketchfab where you can create sort of groups of models with different licenses. One of the ideas, and you see it, here's already some scanned assets that people have uploaded here. So it's a park bench that somebody's uploaded. This is already possible. We could basically create a repository of New York City scanned streetscape objects that have been optimized and then give them away or make them open data. And people could do all kinds of things with that. I think that would be neat. So I kind of want to start one. And yeah, I think that would be really cool. There's some new tools the city released, like a ADU, accessory dwelling unit guide. And I've seen more and more places releasing pre-approved housing guides. So if you want to have an easier time building an apartment in your backyard, you can use Burlington or Canada's guide or New York City's guide that has plans in it, but they're floor plans. And I think releasing 3D models alongside some of this stuff would be very useful because you can preview how it would look in your backyard and do all kinds of things with it. Not to mention put it in games, reach people where they are digitally. There was an article that some kids on Roblox had recreated the Boston MTA full bus system with working buses, and it's like hyper realistic. So it would be very useful, I think, to have these assets for all the kinds of reasons, not just AR. Someone said envisioning access to resources is a big part of open space advocacy, and I see a lot of potential for that, either through AR stills or more elaborate AR demos. Excited to see how this grows. That's awesome. I haven't had time to connect with the Mapping for Equity project, although I was a donor and I met some of them at the OpenStreetMap conference. But yeah, I think the process is as important as the product here. I learned this from the digital heritage folks as well. Like, they don't just go and scan themselves. They actually recruit volunteers in Tunisia to do the scanning. And so their participation helps to grow awareness around the topic they're discussing, which is like, they don't have very much official preservation bodies there. So they have to grow community as well as it's not just an archive, it's like a movement. So I think that would hold true here as well. And it would be cool to get the app set up in a way that people could go out and do it as a group together, stuff like that. And obviously education and helping to spread these skills is going to be pretty useful. This is already a genre of filmmaking. There's volumetric filmmaking, and the Museum of the Moving Image in Astoria has a new tech lab where they're teaching some of this stuff as well. I think definitely a desirable thing to learn. More questions? Not, I think I'm just about running dry. There's all kinds of things I can share. But thank you, Kathleen. Regarding the skills, you'd be surprised. I think it was this project actually where this shade structure where our client in New Orleans was working with senior citizens in the neighborhood, and they brought iPads out and were looking at them together, the designs, and that's what helped them take the final push and say, okay, let's build this, because there were questions and reservations and stuff. I found that there's a horseshoe, we've done projects with paper, for kids as young as kindergartners. Their teacher had them make paper models and scan them, and we put them in a park. And then we've also had projects working with senior citizens as well. A good place where those two groups meet, by the way, is Gotham Park under the Brooklyn Bridge on the Manhattan side, whose primary users are senior citizens from Chinatown and skateboarders, because it's a famous skateboard spot. So they have a new group, Gotham Park, that's building that community up. And as they renovate and open up sections of it, we did the block party that they hosted last year, where we did that kindergarten project and another tech high school nearby, showing some of their street furniture designs. They're having the block party again on May 2nd. So Gotham Park block party May 2nd. We will be there with some demos that you can try out. And then on May 3rd, we're doing a Jane Jacobs walk with Union Square Partners. Our One of our old designers has made an AR sort of extension of a public sculpture by Fitu Carroll, the artist. It's like a red metallic sculpture called Recess Reads. If you see it in Union Square, there is a AR QR code that opens up like a bunch of other elements up floating around the city around if you scan it at the sculpture. So we're going to walk through some public art there, take a look at the AR activation, and then I'm going to go scan the actual sculpture and leave everybody with a copy to take home with them so you can take the sculpture anywhere else. Hope to see you if you're around in May. Be great to connect again, and do reach out. I think my contact is at the end of presentation here. There we go. So Nick at institute.us. I love doing this stuff, and we really need some revenue. So if you do work for a planning agency or large AEC company, community-based orgs, we can collaborate. But yeah, if you're a larger org, let us teach you this stuff. It's not going away, and I've met a lot of architecture firms that have tried AR and maybe given up because it was for us really frustrating 5 years ago. But now it's come a long way, I'll say, and there's a lot more things you can do. Oh, and you had a comment on history. Yes, absolutely. Like, history tours, I think, are where AR has the biggest penetration. So arts and history and sort of downtown groups. There's so many history tours. If you look up for your city, probably at some point there's an AR history tour. And then any advice for using photos, like not 3D and old iPhones like 12. So there are some older iPhones that will still support AR and stuff like that and photogrammetry, because you don't need a LiDAR sensor or anything to do the photogrammetry, just photos. So you could actually use photos taken historically if you had enough angles to recreate. I've done some experiments with historical photographs and doing 3D from them. And then you can also just use photos. So I've put like old photos on a flat plane in 3D in AR, just to line up like a historical postcard, line it up with the space. And that works too. So it's just, your 3D model is just a 2D sort of postcard instead of a 3D model. I'm going to just find the Gotham Park website for people so you can check out their event. Here's their page. I will just put the link to Institute. We're more of an enterprise product, and you can look up different solutions, but we do still have a free trial, I believe, and you can publish a project. So if you want to try it out, and of course, if you make a video, that lasts forever too, definitely give it a try if you like, and let me know if you need any help.